Annex A.8.19 governs how software is introduced into operational systems. The control's objective is to ensure that every application, update, or utility installed on live systems has been properly vetted, approved, and documented. This applies to production servers, critical endpoints, network appliances, and even virtual machines spun up in cloud environments. It requires clear boundaries between development, staging, and production environments, preventing experimental or untested code from leaking into live systems. Administrative privileges must be limited, and all installation actions should create audit trails for accountability. When implemented well, the result is an environment that evolves safely, one where change occurs deliberately rather than accidentally. The risks of uncontrolled software installation are both technical and organizational. Malware, backdoors, or spyware can easily masquerade as useful utilities, embedding themselves deep within production infrastructure. Even legitimate but untested software may cause instability, conflicts, or unanticipated downtime. Licensing violations can introduce legal exposure, fines, or reputational harm, especially in regulated industries. Shadow IT, systems or tools deployed without approval, creates invisible risk by bypassing security baselines and patch management cycles. Each unauthorized installation undermines the consistency and trustworthiness of production environments, creating blind spots for both security teams and auditors. A.8.19 prescribes a set of control measures to counter these risks. Organizations must implement a formal approval process that documents requests, justifications, testing outcomes, and final authorization before any software reaches production. A whitelist or catalog of authorized applications ensures that only sanctioned packages can be installed, reducing exposure to unknown binaries. Centralized logging records all installation events, enabling retrospective review of changes. Periodic inventory checks compare actual installed software against the approved list to identify anomalies or outdated components. These measures may sound procedural, but they prevent chaos by ensuring that every executable inside the environment is traceable to a decision and a responsible person. Auditors assessing compliance with A.8.19 look for evidence of structure, oversight, and discipline. A clear policy should exist restricting installations to authorized personnel, often system administrators or platform owners with defined roles. Change control tickets, approvals, or documented risk assessments demonstrate that each installation followed due process. Auditors may sample system inventories, cross-checking installed applications against approved lists to confirm adherence. Logs showing denied or blocked installation attempts indicate that enforcement mechanisms are active, not just theoretical. This evidence reassures stakeholders that the production environment operates within a controlled perimeter, minimizing opportunities for drift or compromise. Illustrative scenarios show how these controls apply in practice. A contractor might install personal troubleshooting tools on a company laptop, unintentionally introducing malware that spreads to the network. An administrator may deploy unlicensed software, triggering compliance violations and unexpected audits. Emergency patches applied outside the normal approval process can cause outages that ripple through dependent systems. Cloud engineers might spin up virtual servers using insecure default images preloaded with unnecessary packages. Each incident demonstrates how convenience or haste, if unchecked, can erode operational integrity. Discipline and installation processes protects not just systems, but also organizational reputation. The business benefits of A.8.19 compliance are measurable. Controlled installations create stable production environments with fewer failures, improving uptime and customer confidence. Reduced exposure to rogue or compromised software strengthens defenses against data breaches and ransomware. Licensing compliance eliminates the financial and legal risks associated with unauthorized tools. Predictable vendor relationships and standardized builds improve supportability and simplify audits. Most importantly, this discipline fosters a culture of accountability, where every piece of running software is visible, justified, and maintained as part of a larger security ecosystem. Different industries apply these controls according to their operational realities. Banks restrict software installation on trading platforms to preserve transaction integrity and meet regulatory scrutiny. Hospitals lock down operating systems on medical devices so unauthorized applications cannot interfere with patient care systems. SaaS companies enforce golden images for production servers, ensuring each deployment adheres to a hardened, repeatable baseline. Government agencies often require digital signatures on all software installations to ensure authenticity and provenance. In every sector, A.8.19 translates into the same outcome: confidence that what is running in production truly belongs there. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Annex A.8.20 extends the concept of operational discipline from individual systems to the digital highways that connect them. While A.8.19 ensures that only trusted software runs within an environment, A.20 ensures that data moving between those systems remains protected. Network security is the circulatory system of modern organizations, constantly transmitting sensitive information among users, servers, applications, and external partners. ISO/IEC 27001 positions this control to uphold confidentiality, integrity, and availability across all networked environments, from on-premises data centers to hybrid and multi-cloud architectures. The objective is to create a layered defense where boundaries are well-defined, internal pathways are segmented, and malicious activity cannot traverse the network unnoticed. At its core, network security under A.8.20 requires a design that safeguards every layer of data transmission. Segmentation divides networks into zones based on function and sensitivity, limiting the spread of malware or unauthorized access. Firewalls enforce traffic rules between these zones, filtering packets based on policy and reducing the attack surface. Intrusion detection and prevention systems, IDS/IPS, analyze traffic patterns in real time, identifying potential exploits or anomalies before they cause damage. Secure remote access, whether through VPNs, Zero Trust Network Access, ZTNA, or other secure channels, ensures that users connect safely without exposing the network perimeter. Encryption in transit protects data from eavesdropping or manipulation, making intercepted communications useless to attackers. Collectively, these mechanisms form a digital barrier that transforms open connectivity into controlled, observable flow. Operational excellence in network defense demands continuous governance. Baseline configurations for routers, switches, and firewalls must be hardened and documented, eliminating default credentials, unnecessary services, and unused interfaces. Change control processes ensure that every rule modification, from a firewall exception to a routing update, follows formal approval and testing procedures. Network monitoring captures logs and telemetry, feeding them into centralized analysis systems to detect anomalies, intrusion attempts, or unusual outbound connections. Vulnerability scanning and configuration assessments identify weak points before adversaries exploit them. The philosophy is proactive maintenance, preventing misconfiguration rather than reacting to compromise. The risks mitigated by A.20 are both familiar and evolving. Unencrypted traffic can be intercepted by attackers, exposing credentials, payment data, or personal information. Flat network designs allow lateral movement once an intruder gains access, enabling ransomware or advanced persistent threats to spread uncontested. Denial of service attacks can overwhelm poorly segmented or unprotected networks, interrupting business operations and eroding customer trust. Unmanaged network devices, often forgotten legacy hardware, can harbor backdoors or outdated firmware that attackers exploit as hidden entry points. Implementing layered controls under this annex ensures that even if one barrier fails, multiple others stand ready to contain damage. Auditors reviewing network security controls expect tangible evidence that defenses are designed, implemented, and continuously maintained. Comprehensive network diagrams should clearly illustrate segmentation boundaries and data flows. Firewall and router configuration reviews demonstrate that rule sets are appropriate, documented, and periodically validated. Logs and monitoring reports confirm that oversight is active, with anomalies investigated and resolved. Penetration test results provide independent assurance that perimeter defenses, encryption, and segmentation perform as intended. These artifacts give regulators and clients confidence that the organization's network operates under deliberate management rather than unexamined complexity. Failures in network security often reveal themselves through high-profile breaches. Credentials transmitted in clear text over public Wi-Fi can be intercepted in seconds, granting attackers internal access. Flat enterprise networks enable ransomware to leapfrog from a single infected endpoint to entire data centers. Critical systems reachable from internet-facing segments, a result of poor segmentation, invite exploitation from opportunistic scanners. Weak or reused VPN credentials, left unmonitored, have become entry points for large-scale intrusions. Each example demonstrates that the network is both a strength and a weakness. It connects everything, and without controls, it exposes everything. Industry-specific implementations show how the same principles scale across contexts. Financial institutions enforce strict segregation between payment processing networks and corporate IT to protect transaction confidentiality. Healthcare providers encrypt all traffic containing medical images or patient data, meeting privacy laws and protecting life-critical systems from interference. Utilities maintain redundant communication paths for SCADA systems, ensuring that control operations continue even if one link fails. Retailers use tokenization gateways that isolate payment card data from broader networks, reducing compliance scope and fraud risk. Across all these sectors, ISO's message remains clear. Connectivity must be accompanied by control, and efficiency must never outrun security. Annexes A.8.19 and A.20 reinforce each other in practice. Secure software installation prevents vulnerabilities and rogue applications from undermining network defenses, while network controls protect those operational systems once they are deployed. If installation discipline ensures that only trusted components run, network discipline ensures that only trusted communications occur. Together, they create a self-reinforcing model of operational assurance, internal integrity safeguarded by external defense. Auditors recognize this interplay as a hallmark of mature ISMS environments, where production systems are both locked down and well defended. When fully realized, these two controls transform infrastructure management from reactive firefighting into proactive reliability. A.8.19 ensures that nothing enters the operational ecosystem without validation. A.20 ensures that nothing leaves or moves through it without protection. They represent the convergence of IT operations and cybersecurity governance, proving that secure environments are not built by isolation but by intentional integration. By enforcing disciplined installation and layered network protection, organizations establish production environments that are not only functional but resilient, trusted by auditors, customers, and regulators alike, even when the unexpected occurs.